In this video, we're going to talk about finding probabilities for a standard normal distribution using a table. So before we talked about standard normal distributions as being normal distributions where the mean is 0 and the standard deviation is 1. And we said they all have bell-shaped curves that are symmetric, as does any normal distribution. So we had a particular example of a freeze pop and saying that those are normally distributed with a mean of 0 degrees Celsius and a standard deviation of 1 degree Celsius for their temperature. And we said, what is the probability that a temperature of a randomly selected freeze pop is less than negative 1.78 degrees Celsius? So that probability technically is equal to the integral from negative infinity up to negative 1.78 of 1 over the square root of 2 pi times e to the negative x squared over 2 with respect to x. And that integral is equal to that red area, that shaded area under the curve, and it's also equal to the probability that we're interested in. However, essentially no one finds these probabilities using that integral. This is where it comes from when we look at a table or a computational device. But those values have been calculated because they are very common values to want to find for normal distributions in general, not specifically for standard normal distributions. Finding the probability that a data value is within a certain range in a normal distribution with a given mean and a given standard deviation. And therefore, some tools available are tables or calculators that have this property, or different web calculators. And in this particular video, we're going to focus on finding these probabilities using a table. So these tables are, here are two such tables below. These are called z-score tables or standard normal tables. Remember, as we said before, that a normal distribution is already, each of the data values are already z-scores, because the z-score is the number of standard deviations a data value is above or below the mean, and we have a mean of 0, a standard deviation of 1, so any data value on a standard normal distribution is already a z-score. So a lot of tables are separated like this, one we see below, into a negative z-score side and a positive z-score side. And so we are going to see using the table to find these probabilities. So let's use the table to find the probability that this freeze pop is less than negative 1.78 degrees Celsius in temperature. This z-score has the first two decimal places in the column and the last decimal place in the row. So the negative 1.78 we'll find in the column. Here is negative 1.7, so there's that value. And then the second decimal place is a 0.8, so we're in this column, we're in this row. And we see where they match up, and we see that they match up here. They match up at 0.0375. So our probability that z is less than negative 1.78 is 0.0375. And that is our probability. And again, that corresponds to the probability under the curve below negative 1.78. So it corresponds to this shaded region under the curve. These tables always give the probability that z is less than a particular value. So if we want to find the probability that z is greater than a particular value instead, here we want the probability that this freeze pop is has a temperature greater than negative 1.78. So now we want this probability instead, this larger shaded region. So think for a minute about what the relationship is between the shaded region that we see above, the shaded region that we see here, and the shaded region that we see down here. What is the relationship between those two shaded areas? Well, we know that the total area under the curve is 1. So for any continuous probability distribution, the total area under the curve is equal to 1. So if we want to find the probability that z is greater than negative 1.78, this is going to be equal to 1 minus the probability that z is less than negative 1.78, because those two values add up to 1. So to find one from the other, we can subtract it from 1. And so this is equal to 1 minus the probability we already found, 0.0375. And so that is 0.9625. 0.9625 is the probability that this freeze pop has a temperature greater than negative 1.78. And any time that we want to find the probability that a normal distribution has a value greater than a particular value, we're always going to find the probability for less than and then subtract that probability from 1. Okay, suppose scores on a personality test are normally distributed with a mean of 0 and a standard deviation of 1. If an individual is randomly selected, what is the probability that their score is between 0.53 and 2.4? So between, here's 0.53 and here's 2.4. What is the probability that our randomly selected data value falls within that range? This is probability that 0.53 is less than z, which is less than 2.4. And again, this is equal to the area under the curve of the probability distribution from z equals 0.53 to z equals 2.4. So we're looking for that probability. And remember that this table always gives these probabilities in terms of being less than a particular value. So we can find the probability that z is less than 2.4. We can find the probability that z is less than 0.53. So for now, just think for a second about if you're able to find each of those probabilities separately, how could you find the probability of the shaded area that we're interested in, the probability that z is between 0.53 and 2.4? Okay, if we're able to find each of those probabilities separately, say that in green here is the probability that z is less than 2.54. So in green, we've got the probability that z is less than 2.4. And then let's say that in red, we've got the probability that z is less than 0.53. And we can shade that in red. So here is the probability that z is less than 0.53. Again, we can find each of those probabilities using the table. Table always gives probabilities in terms of less than. And what we want is this shaded piece in the middle. So we want this piece in the middle. And to find that value in the middle, what we can do is take the probability in green, the probability that z is less than 2.4, and subtract from it the probability in red, the probability that z is less than 0.53. So in other words, the probability that we're looking for, the probability that 0.53 is less than z, which is less than 2.4, is equal to the probability that z is less than 2.4 minus the probability that z is less than 0.53. And so we can find each of those probabilities separately using our table. So finding the probability that z is less than 0.53, here's our 0.5, and here's the second decimal place of 0.03. And so the place those two values match up, 0.7019. So this is 0.7019 for that second probability. The probability that z is less than 2.4, we would have, here is 2.4, and then the second decimal place is just 0, 2.40. So the place where those match up is right here, 0.9918. So we've got 0.9918 minus 0.7019, and now we just need to subtract. And subtracting gives us 0.2899. So the probability that we're in between those two values is 0.2899. So I'd like you to try a few yourself. If we know that a set of data comes from a standard normal distribution, what is the probability that a randomly selected data value is greater than negative 1.57, less than negative 1.57, and between negative 1.57 and 2.4. And for each of these, just grab a piece of paper and sketch the standard normal distribution like this, and then shade in the probabilities that you're interested in for each of these parts. Okay, for the probability that the randomly selected data value is greater than negative 1.57, so here's negative 1.57 approximately, and we're looking for this shaded value being greater than that value. So because we're looking for a greater than, that means we're going to have to subtract from 1 because the table always gives less than. So let's first find that table value, negative 1.5, and 0.07 is the second decimal place. So the place where those two values match up, 0.0582. So that is our probability that we're actually over here, that we're less than negative 1.57. And that, makes sense with thinking about this 0.0582, that's less than a half, less than 0.5. So that wouldn't make sense as the black shaded area, because the black shaded area is clearly much larger than a half, whereas the green shaded area is more along the lines of something close to 6% or 0.058. So the probability that z is greater than negative 1.57 is equal to 1 minus the probability that z is less than negative 1.57. And so that is equal to 1 minus 0.0582. And so that is 0.9418. So 0.9418 is the probability of this black shaded region that this data value is greater than negative 1.57. For a probability that it's less than negative 1.57, well, we've already found that because the table already gives things in terms of less than, so it's this value we've already found. The probability that z is less than negative 1.57 is equal to 0.0582, so that is our probability. If we wanted to draw that, here is around negative 1.58. Here's the shaded region that we're talking about, a probability of 0.0582, or about 6%. Finally, between those two values, this is negative 1.57 and positive 2.4. So we're looking for the probability that we fall between these two shaded values. Anytime we're looking for a between, we can take the probability that we're less than the larger one and subtract away the probability that we're less than the smaller one. So basically, we're finding all this green area, probability that z is less than 2.4, and we're subtracting away the red area, we're subtracting away the probability that z is less than negative 1.57. So again, the probability we're interested in, the probability that negative 1.57 is less than z, which is less than 2.4, is going to be equal to the probability that z is less than 2.4 minus the probability that z is less than negative 1.57. And so that's equal to, we found each of these probabilities above. So the probability that z is less than 2.4, we found to be, we found to be 0.9918. So 0.9918 is the first probability, the green, 0.9918, minus the probability that z is less than negative 1.57, we found just above to be 0.0582. And then we can just subtract these values, and this will give us 0.9336. So that is the probability of the shaded region that we're interested in, 0.9936.